Hello friends, welcome back to your loving channel Sea Level Physics. My name is Srinivas, familiar to be B.S. Rao. So in this lecture I would like to explain some numericals based on distance and displacement. Okay, before that here we have some quantities like distance, displacement, speed, velocity, acceleration, momentum, kinetic energy, power, work done, etc. These quantities may differ from one kind of frame of reference to another kind of frame of reference. That is from inertial frame to non-inertial frame. So that is the reason why quantities like distance, displacement, speed, velocity, etc. are said to be frame dependent. Means they depend upon frame of reference, whether it is inertial frame or non-inertial frame. So that is the reason why these quantities are also known as relative quantities. Frame dependent, otherwise relative quantities, not absolute. These quantities are not absolute. Okay, but coming to one quantity, that is the time of event. What is time of event? It is the time at which event occurs. Given event occurs is known as time of event. But whatever the kind of frame of reference, the time of event remains same in all frames of reference. So that is the reason why this time of event is said to be frame independent. Means it does not depend upon frame of reference. So that is the reason why this is also known as absolute. It's not relative. So time is not relative, that is absolute. Okay. But now coming to numericals. See here we have a numerical. A motorcyclist rides in a ground such that after every 50 meters he takes a left turn through 60 degrees. Okay. Find the magnitude of displacement and distance suffered by him just after ninth turn. See here. Here. This is the starting point of the motorcyclist. O is the starting point. Okay. He started from point O and covers 50 meters straight away. Okay. At point A, he takes left turn through 60 degrees. Again, covers 50 meters. On reaching point B, he takes left turn through 60 degrees once again and covers 50 meters. But at point C, he takes left turn through 60 once again and so on. So, after covering every 50 meters along straight line, he takes left turn through 60 degrees and so on. Okay. But the question is, find the magnitude of displacement and distance suffered by him just after ninth turn. Just after ninth turn. Okay. Just after ninth turn, estimate the position of the motorcyclist. For example, Y is the starting point or initial position. Okay. This is the first turn after covering 50 meters. This is what 50, this is what 50, 50 meter and so on. Okay. So, after ninth turn, estimate the final position of the motorcyclist. See, this is the first turn. If O is the initial position, A is the first turn. At point A is the he takes first turn. At point B, second turn. At point C, third turn. Here, fourth turn, fifth turn, sixth turn. Here again, eighth turn. Seventh turn. Here, eighth turn. Here, ninth turn. Okay. Just after completion of ninth turn, he reaches position C. So, O is the initial position, C is the final position. Okay. Now, I am writing somewhere here. O is the initial position. Right. O initial position. Right. C is the final position. Am I right? Very good. Now, what is the distance? Distance means, what is the distance? Total length of the path. Total length of the path. Am I right? Now, what is the total length of the path? See, 50 plus 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 50. Just after taking left hand at C, okay, he covers 9 times 50 meters. 1 into 50, 2 into 50, 3 into 50, 4 into 50, 5 into 50, 6 into 6 into 50, 7 into 50, 8 into 50, 9 into 50. So that is 9 into 50, that is 450 meters. Am I right? So as far as definition is concerned, what is the meaning of distance? It is the total length of the path, right? As he took 9 turns, okay, after every 50 meters along a straight line he takes left turn. So that is the reason why 9 into 50 meters. Therefore 450 meters, right? Now coming to displacement. Displacement. What is meant by displacement? A line segment joining from initial position to final position, irrespective of path followed. Whatever the path taken by the motorcyclist, we don't bother. Simply, we have to consider initial and final position. Y is the initial position, C is the final position. So, what is the displacement here? OC is the displacement. See, OC is the displacement. OC is the displacement. That is OC. OC is the displacement. A line segment joining from initial position to final position with a directed arrow is the displacement. Now the length of this arrow is nothing but magnitude of displacement. What is the length of this arrow from O to C means? See, we have one regular hexagon here. Regular hexagon in the sense 6 sides, equal sides. 50, 50, 50, 50, 50, 50 meters, right? Equal sides. Okay. Regular hexagon in the sense it consists of 6 equilateral triangles. Where are the 6 equilateral triangles here? See, right? I am writing one more line, horizontal line somewhere here. See, this is what one equilateral triangle. This is the other. First one, second one, third one, fourth one, fifth one, and sixth one. Right? Equilateral triangle in the sense all sides are identical, means of equal length. It is 50 meters. This side also 50 meters. This side also 50. Here 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 also 50. Now what is the length of OC? 50 plus 50. Right? 50 plus 50. That is 50 plus 50. That is 100 meters. 100 meters. From O to C means 50 plus 50. 100 meters. From O to C. Right? So that's how one can estimate distance covered and displacement covered by motorcyclist. Okay. Now coming to one more numerical. See here. One more sum. In second sum, a particle moves in a xy plane as shown. XY plane, right? See next sum. This is what XY plane. This is y axis. This is x axis like that. This is point O, origin. Now a particle starts from O, moves through 5 centimeters from O to P, right? Again from P to Q through a distance 6 centimeter parallel to x-axis. See, parallel to x-axis. From P to Q means he covers or that particle covers through a distance of 6 meters parallel to x-axis. And again, finally from Q to R like that. Q to R covers through a distance of 4 centimeters. 4 centimeters. See here O to P 5 centimeters, P to Q 6 centimeters, and again Q to R 4 centimeters. Right? This is the path followed by one particle. Now find the total displacement of the particle. Total displacement. displacement of particle. Right? What is meant by displacement? A line segment drawn from initial position to final position. O is the initial position, R is the final position. Am I right? Irrespective of path followed. Okay, no need to consider total path covered. Simply we consider initial position and final position. Draw a line segment from initial position to final position like this. See, this is what initial position, final position. See this directed line segment like that. Otherwise, this is the displacement, in fact, right? Displacement from O to R. If I close this side also like that, see this side, we have one right angle triangle like that. See, right angle triangle. In this right angle triangle, hypotenuse is the displacement. Am I right? Hypotenuse is the displacement. See, hypotenuse. Say O, P, Q, R, let be S like that. So, right angle triangle O, S, R. O, S, R. In that right angle triangle O, S, R. OR is the displacement. OR is the displacement. Right? Displacement. Am I right? Now say this segment is of 4 centimeter. Now what about the segment? We need to find here. Of course, here one angle also given. What is the angle made by this 5 centimeters with x-axis means that is 37 degrees as an example. 37. Right? If I close this side, now we can estimate adjacent side from here to there, opposite side from here to there also. Right? Suppose here S dash as an example. Triangle O, S dash P. In this right angle triangle, this is what 5 centimeter. 5 centimeter. What is the angle here? 37 degrees. Right? Now what about opposite side? What about adjacent side? See, what about opposite side? Tan 37. Tan 37 equal to 4 by 3. This is what 4, this is what 3. Right? These are familiar values. Tan 37. 3 by 4. 3 by 4. Opposite side by adjacent side. That is tan 37 equal to 3 by 4. Similarly, cos 37 equal to 4 by 5. These are round figure values. Okay, noted values. That is cos 37 equal to 4 by 5. Adjacent side by hypotenuse. That is 4 by 5. Similarly, sin 37 also equal to opposite side by hypotenuse, that is 3 by 5. Okay, 3 by 5. Of course, here 90 degrees. Here, what about the rest of angle? Here 90 plus 37. Here 180 minus 90 plus 37, that is 53 degrees here. 53. All together forming 180 degrees. That is 37 plus 53 plus 90. That is 180. In this triangle, what about cos 37 adjacent side by cos 53? Cos 53 means adjacent side by hypotenuse, that is 3 by 5. See, once again, tan 37 okay. What about tan 53? Tan 53 equal to tan 53 opposite by adjacent, that is 4 by 5. 4 by 3. 4 by 3. What about cos 53? Cos 53 equal to adjacent side by hypotenuse, that is 3 by 5. Similarly, sin 53 equal to opposite side by hypotenuse, that is 4 by 5. See, tan 37 3 by 4, tan 53 4 by 3. Cos 37 4 by 5, cos 53 3 by 5. Right? Next, Sin 37, 3 by 5. Sin 53, 4 by 5. These are the common values in solving any sum. Okay. We should remember all these values. Now see, from P to Q, what is the measurement? 6 centimeters. 6 centimeters here. If you know this measurement also, from O to S, that is adjacent side. This is opposite side. Now what is the displacement? Hypotenuse, right? Now what is this measurement means? Take this measurement. What is that measurement? 4 centimeters, right? 4. So from here to there, 4 centimeters, right? Now what is this measurement? Means 3 centimeters. 3 centimeter. Now say, what is this measurement from O to S? O to S. O to S means 6 plus 4 centimeter. Total 10 centimeters. See, 6 centimeters plus 4 centimeter. That is 10 centimeter. 10 centimeter. Right. Now what about measurement from S to R? S to R means here it is 4 centimeter. What about this measurement? That is 3 centimeter. These two measurements are identical. That is S dash to P is 3 centimeters. Similarly, S to Q also 3 centimeters. So 3 plus 4, that is 7. 3 plus 4, that is 7. Now what about displacement from O to R? O to R means hypotenuse. We know remaining two sides, that is 7, 10. 7 centimeters, 10 centimeters. Now what about displacement? That is nothing but hypotenuse. What about the hypotenuse? Root over side square plus side square. So displacement equal to root over 10 square plus 7 square. Root over 10 square plus 7 square. That is root 100 plus 49. That is root 149 centimeters. Root 149 centimeters. Right? Okay. Of course, alternate method also there here in finding displacement. What is that alternative method? In vector notation. See, from P to Q, 6 into I cap. What is the unit vector along x-axis? I cap. So 6I cap, here it is 4j cap. Parallel to y-axis means j cap is the unit vector. So 6I cap, 4j cap. Now what about this displacement? 5 cos 37 into I cap plus 5 sin 37 into j cap. Right? One more method in solving displacement. Let us see. What is that method? What is that method? Adding all individual displacement to get total displacement. Say this is S1 bar, this is S2 bar, this is S3 bar. To find total displacement, S bar equal to S1 bar plus S2 bar plus S3 bar. In that method also we can solve total displacement covered by the particle. Right? Am I right? So in vector notation, say this is S1 bar. S1 bar means S1 bar equal to 5 cos 37 into I cap. 5 cos 37 into I cap. Okay. Plus 5 sin 37 into j cap. 5 sin 37 into j cap. Okay. X component into I cap. X component into I cap plus y component into j cap. What is x component here? 5 cos 37. How to get that value? See once again. Here one triangle is there somewhere here. This is 5. This is 37. Say this is x. This is y. Now cos 37. Cos 37 equal to x by 5. Adjacent side by hypotenuse. Now x equal to 5 cos 37. Similarly, to get y, take sin, that is sin 37 equal to opposite side by hypotenuse, that is y by 5. Y by 5. So y equal to 5 sin 37. 5 sin 37. So we have x component, y component. So if I express 5 centimeter in this plane into vector notation, that is x into I cap plus y into j cap. So S1 bar equal to OP bar equal to S1 bar equal to x into I cap plus y into j cap. That is x into I cap plus y into j cap. What is x? That is 5 cos 37. 5 cos 37 into I cap plus what is y? 5 sin 37. 5 sin 37 into j cap. That is 5 into cos 37. Now I told you that cos 37, that is 4 by 5 into I cap plus 5 into sin 37, that is 3 by 5. 3 by 5 into j cap. So 5 cancel, we left with 4I cap plus 5 cancel 3j cap. So this is what OP bar, that is S1 bar. S1 bar. Now coming to PQ bar. So PQ bar equal to that is S2 bar equal to, these are individual displacements, S1 bar, S2 bar, S3 bar. To get total displacement, add all the three, that is S1 bar plus S2 bar plus S3 bar. Now what about S2 bar? That is 6 into I cap. 6 into I cap. How to get that form? Vector equal to magnitude multiplied by unit vector. That is 6 into magnitude, 6 into I cap is the unit vector along x-axis, right? Now what about QR bar? QR bar equal to that is S3 bar equal to 4 j cap. 4 j cap. Why? Because this is parallel to y-axis. J cap is the unit vector along y-axis, that is magnitude 4 into j cap. Now what is total displacement? S bar equal to S1 bar plus S2 bar plus S3 bar. That is S1 bar 4i plus 3j plus S2 bar means 6i plus S3 bar 4j cap. 4j cap. Now add similar components, that is 4i plus 6i 10i cap plus 3j plus 4j, that is 7j cap. This is total displacement. We got same expression once again as in the previous case, right? That is mod S bar, magnitude of displacement equal to root over x square plus y square. That is 10 square plus 7 square. 10 square plus 7 square. 100 plus 49, root 149 centimeter. Okay, so like that in this method also we can determine distance and displacement, right? Distance in the sense, add all the three segments, 5 plus 6 plus 4. Distance, include all the segments to get total length of the path. Total length of the path means 5 plus 6 plus 4. That is 5 plus 6 plus 4. That is 15 centimeter. This is what distance. Distance 5 plus 6 plus 4. We have to include each and every segment to get total length of the path, right? Okay. Next numerical, aeroplane. Displacements covered by aeroplane, right? Here, for aeroplane moves vertical up through 500 kilometers, right? An aeroplane moves vertically up through 500 kilometers. And moves through 1000 kilometers in a direction and moves through 1000 kilometers in a direction 37 degrees south of east and finally moves through 1000 √2 kilometers northeast. Find total displacement. This is the given question. An aeroplane moves vertical up through 500 kilometers and moves through 1000 kilometers in a direction 37 degrees south of east, and finally moves through 1000 √2 kilometers northeast. Find total displacement. Right? I am taking directions here. See, directions. Okay, this is one clear. I am trying to note directions: north, east, south, west, like that. North, south, east, west. These are the geographical directions here: north, south, east, west. All are locating in this plane, right? In this plane. Now, aeroplane moves vertical up through 500 kilometers like that. 500 kilometers. See, this is origin. From this position, vertical up, it moves through 500 kilometers vertically up, right? 500 kilometers vertically up, right? From which it moves in a direction 37 degrees south of east. South of east. South of east. South somewhere here, east somewhere here. South of east in the sense, this that aeroplane moves in this fourth quadrant like that. See, it moves vertically up. Okay, from which it moves in a plane that is containing fourth quadrant. See, first quadrant, second quadrant, third quadrant, fourth quadrant. South of east, 37 degrees south of east means that 37 degrees is taken with east. Suppose after covering 500 kilometers vertically up, it moves in a plane that is in the fourth quadrant like that. First quadrant, second, third, fourth. So it moves in this plane in the fourth quadrant. See, this is what fourth quadrant. 37 degrees south of east means that angle is taken with east, but it moves in this plane, fourth quadrant. I am shifting that vector parallel to itself and joining somewhere here in this plane like that. See, what is that value? 1000 kilometers. 1000 kilometers. 37 degrees south of east. Of east means angle is to be taken with east one. That is 37 degrees. See, once again, it moves vertical up, covering 500 kilometers. From which, in which direction it moves means in fourth quadrant like that. South of east. Fourth quadrant means like that. Fourth quadrant. I am shifting that individual vector, displacement vector, parallel itself and joining somewhere here in this fourth quadrant like that. Okay. Nothing is mistake by doing like that. Simply I am shifting that displacement vector from top to bottom and trying to joining somewhere here like that, right? S1 bar, S2 bar. S1 bar is due vertically up, but S2 bar is in the fourth quadrant, such that making 37 degrees with east. Am I right? So these two displacements over. Okay, noting of these two displacements over. Now, what is the final displacement? Finally moves through 100 √2 kilometers northeast. Northeast in the sense bisecting first quadrant like that. In fact, not moving on the ground, but that is moving in mid-air like that. See, first vertical up and again in fourth quadrant and again in northeast. Northeast means bisecting like that. It moves in first quadrant like that. Okay, it moves like that. First along in the first quadrant like that. I am shifting that vector from top to bottom and trying to join somewhere here. In fact, this is moving like that finally, but that vector is to be shifted parallel to itself like that and join somewhere here in the first quadrant like that. So northeast in the sense it should bisect this plane. Bisects in the sense here 45 degrees, here also 45 degrees. So bisecting. Northeast in the sense bisecting. See, this is what one plane like that. Once again, see, this is the given plane. This is the given plane. Once again, I am writing directions like that: north, south, east, west, like that. Right? So northeast in the sense midway of north and east like that. So this is what northeast. Bisecting means 45, 45, dividing into equal halves like that. So what about northwest? Northwest in the sense bisecting second, that is quadrant, second quadrant, right? Okay, that is 45, 45. Now what is southwest? Once again bisecting like that, 45, here also 45. What about southeast? Here in the fourth quadrant bisecting like that, into 45, 45. So this is what northeast, this is what northwest, this is what southwest, this is what southeast. Okay. Northeast in the sense bisecting first quadrant, that is angles, equal angles, 45, 45. Northwest also 45, 45, bisecting second quadrant. Southwest also bisecting 45, 45. Southeast also bisecting into two equal halves, that is 45, 45. In our sum, what is the final displacement? That is finally moves through 100√2 kilometers northeast. See, vertical left, fourth quadrant, and again first quadrant. Fourth quadrant shifted parallel to itself, join somewhere here. Similarly, first quadrant moving like that. Okay, that is also to be shifted parallel to itself, join somewhere here in the plane of ground, right? So S1 bar, S2 bar, S3 bar. Now what is this displacement? That is 100√2, 100√2 kilometers. Now add all the three segments to have final displacement. Okay. Now coming to unit vector, see, this is what x-axis, so I cap. This is what z-axis, means plus k cap. Okay, right? This is what negative y-axis, that is minus j cap. This is what positive y-axis, that is plus j cap. This is what negative x-axis, that is minus I cap. Okay. Now what about S1 bar? See, this is S1 bar, S2 bar, S3 bar. S1 bar means S1 bar equal to 500 k cap. 500 kilometers. Oh, that is k cap. Now what about S2 bar? See, this is S2 bar. S2 bar in the sense 1000 here. 1000 cos 37 into I cap. S2 bar equal to 1000 cos 37 into I cap plus x component into I cap plus y component into j cap. X component over 1000 cos 37 into I cap. What about y component? See, this vector lying in fourth quadrant means x is positive, y is negative. So x is positive. What is that quantity? 1000 cos 37 into I cap. Now what about y coordinate? That is 1000 sin 37 into minus j cap. 1000 sin 37 into minus j cap. So x positive, y negative. On extending 1000 into cos 37, that is 4 by 5 into I cap plus 1000 into sin 37 means 3 by 5 into minus j cap. That is 200 times 200 into 4, that is 800 I cap plus or minus 200 times into 3, that is 600 j cap. Right. Now what about Third vector S3 bar. S3 bar means this is S3 bar. S3 bar means once again, see, x component into I cap plus y component into j cap. See, that vector is located in the first quadrant. First quadrant. See, first quadrant. This is fourth quadrant. So in the first quadrant, both x and y are positive. What is x component? 1000 root 2. 1000 root 2. 1000 root 2. See, 1000 root 2 cos 45 into I cap. 1000 root 2 cos 45 into I cap plus 1000 root 2 sin 45 into j cap. 1000 root 2 sin 45 into j cap. That is cos 45 1 by root 2. Root 2 cancel. Sin 45 1 by root 2 cancel with root 2. We left with 1000 I cap plus 1000 j cap. Am I right? 1000 I cap plus 1000 j cap. Therefore, S3 bar equal, what is total displacement? S bar equal to S1 bar plus S2 bar plus S3 bar. That is S1 bar K cap, S2 bar both I and J, S3 bar both I and J. First add all I components. So 1000 I plus 800 I, that is 1800 I. Am I right? Next, coming to y quadrants, that y component, that is minus 600j, here plus 1000j, that is plus 400j, plus 400j, plus we left with 500k only, right? That is 500k. This vector is in terms of kilometers. Why? Because all are expressed in kilometers only. In all three segments, first segment, second and third, all are expressed in kilometers. So S bar also in kilometers. If you want to get magnitude of displacement, take modulus. Take modulus. Am I right? Take modulus. Modulus of S bar. Modulus of S bar equal to root over x square plus y square plus z square. X square means, otherwise this also can be written as S bar equal to 100 is common in all the three terms, that is 100 into 100 is kept common. We left with 18i plus 4j plus 5k. 5k, that is 100 into, okay, now coming to modulus, mod S bar equal to 100 is kept common. Take the modulus here, that is root over x square plus y square plus z square, that is 18 square plus 4 square plus 5 square, that is 100 into root over 18 into 18, that is 324 plus 4 square 16 plus 25, that is 100 into 324 plus 16, that is 340 plus 25, 365. We left with 100 into, this is what, 19.1. Okay, that is 1910 kilometers. So this is what total magnitude of displacement covered by the aeroplane. Also you can see, initially aeroplane moves through 500 kilometers vertically up, from which 1000 kilometers such that making 37 degrees south of east, that is in fourth quadrant, from which 1000 root 2 kilometers northeast like that. So vertical up, fourth quadrant, second quadrant. So I am shifting the second displacement and third displacement onto plane like that. So S1 as usual, this S2 is shifted down and join here. S3 also shifted down parallel to itself and join here. So S1, S2, S3 all are located in the plane of ground only, right? S1 bar, S2 bar, S3 bar. I am adding all the three, S1 bar plus S2 bar plus S3 bar in vector rotation, like that. And finally, we went for magnitude. That is root over x square plus y square plus z square. Okay, thank you. Now, another sum, that is distance and displacement covered. Distance and displacement covered by a particle when it moves along circle. When it moves along circular path. Am I right? Circular path. See. See here. This is the path followed by the particle. In fact, circular path as shown. Initially, particle is somewhere here and moves along circumference and reaches here. Am I right? So this is the center of the circle. When particle is somewhere here at A, let R1 be the radius vector, R1 bar. When reaches point B, let be R2 bar. In fact, mod R1 bar equal to mod R2 bar equal to R. Why? Because magnitude of radius vector remains same. Magnitude remains same. So here also R, here also R. But why to take R1 bar, R2 bar means? Why? Because the direction of radius vector changes. If magnitude changes or direction changes or both changes, that vector is said to be changed or altered. So that is the reason why here different labels are taken. That is R1 bar, R2 bar. In fact, their magnitudes remain same. Right? That is all. Now what is the angle swept by the tip of the radius vector while going from A to B means let be theta. Let be theta. So R1 bar, R2 bar. Whenever particle moves along circular path, the tip of radius vector also rotates like that. Rotates along with the motion of the particle. Right? When particle is somewhere here, this is R1 bar. When it moves on the circumference like that, radius vector also rotates like that. Along with motion of the particle. Right? Definitely, it moves. The radius vector moves through some angle theta while going from A to B. Am I right? Okay. Now, what is the distance here? The length of this arc is the distance. Why? Because distance is the path covered by the particle. See, this is the path. Arc itself. This arc itself, path. So, by definition, that itself distance. So, the length of arc AB is the distance. Now, what about displacement? Displacement in the sense, a line segment joining from initial position to final position. See, this is the initial position, this is the final position. Now, take a line segment and join from initial to final with an arrowhead. So, this is what displacement. Displacement, S bar. Now, this is distance. Distance. This is displacement, this is distance. Right? Now see, the head of R1 bar joined with the tail of S bar. Tail of S bar. I am highlighting somewhere here, same diagram. See, R1 bar, here it is, R2 bar, here it is S bar like S bar. See, the head of R1 bar joined with the tail of S bar means these two are taken as the adjacent sides of triangle in the same order. Head and tails are joined here. So these two are taken in the same order. Now this is the closing side taken in the reverse order. That is tail of first vector to the head of the second vector. See the direction like that. Means tail to tail joined, head to head joined. So this is out of order. These are in the same order. So therefore, as per triangle of addition, R1 bar plus S bar equal to R2 bar. So R1 bar plus S bar equal to R2 bar. That is S bar equal to R2 bar minus R1. Final position vector minus initial position vector. Here, final radius vector minus initial radius vector. That is also displacement as per the situation here. Am I right? So therefore, see, is it sum or difference? In fact, this is the difference of radius vectors, right? As per parallel law of addition of vectors, if I take modulus of s bar, mod s bar, that is magnitude of displacement equal to root over r1 square plus, root over r1 square plus r2 square plus r1 square plus r2 square minus 2r1 r2 cos theta by definition. Am I right? As per as parallel law of addition of vectors are concerned, that is root over r1 square plus r2 square minus 2r1 r2 cos. In fact, r1, r2 both same in magnitude. So replace with r once again. That is root over r square plus r square minus 2r, that is 2r square into cos. Already we did the same result twice in the addition of vectors. That is mod s bar equal to root over r square plus r square, 2r square minus 2r square cos theta. So 2r square is kept common. We left with 1 minus cos theta. 1 minus cos theta. That is root over 2r square into 1 minus cos theta. 2 sin square theta by 2. That is one result. 2 sin square theta by 2. See, 2 into 2, 2 square, r square sin square theta by 2. That is 2r sin theta by 2 whole square. See, 2 into 2, 2 square, r square, here sin square theta by 2. So, square is common for all the terms. That is square root cancel, we left with the 2r sin theta by 2. This is what magnitude of displacement. Okay. As far as motion of particle along circular path is concerned, to get the displacement, what is this expression here? 2r sin theta by 2. So where r is the radius, magnitude of radius vector, theta is the angle through which radius vector swept, angle through which radius vector moves otherwise, okay, while that path is under motion, right? Now what about distance? Distance d equal to, distance in the sense the length of arc, that is length of arc, length of arc. What is length of arc here? There is one relation between length of arc and radius and angle. What is that length of arc? Arc equal to radius times angle, or theta. So 2r sin theta by 2 is the displacement, radius times theta is the distance. So d is the distance here from A to B, length of the arc, that is arc length equal to radius times angle made by that arc with the center, right? So making use of these two expressions, one can find distance and displacement in various situations in case of circular motion. Let us see. What is the displacement? Displacement equal to r sin theta by 2. What is the distance? Distance equal to arc length, that is r theta. Now let us see. For one revolution, see, suppose particle started from here and makes one revolution like that, means it covers one revolution. Now what is the angle swept by the radius vector? 2 pi radian. See, it moves along circular path from A and again reaches A. Now this radius vector sweeps 360 degrees, that is 2 pi radian. For one revolution, what is theta? 2 pi radian. Now displacement, mod s bar equal to formula, say 2r sine theta by 2, that is 2 pi by 2. 2 or sine theta by 2 pi by 2. That is what? 0. 2 gets cancelled. That is sine pi means 0. Now whatever distance d equal to arc length r into theta. R into theta. That is for one revolution, for one complete revolution, what is the total length of the path? Nothing but perimeter. Perimeter. That is, what is the perimeter of circle? 2 pi r. Here from formula, r into, what is theta here for one complete revolution? 2 pi. That is 2 pi r. 2 pi r. Now for 2 revolutions. 2 revolution means what is theta? For one complete revolution, angle made by the radius vector is 2 pi. For 2 revolutions, 2 complete revolutions, 2 into 2 pi. 2 into 2 pi. 2 into 2 pi. Now displacement mod s bar equal to 2r sin theta. 2r sin theta by 2. What is theta? 2 into 2 pi by 2. Theta by 2. 2 into 2 pi by 2. That is 2 to cancel. Sin 2 pi. Sin 2 pi also 0. Means displacement covered is 0. Right? Now whatever distance d equal to r theta, that is r into, what is theta? 2 into 2 pi. Okay? That is twice 2 pi r. Twice 2 pi r. Here 1 into 2 pi r. Here 1 into 2 pi r. 1 into 2 pi r. Here 2 into 2 pi r. So for one complete revolution, 1 perimeter. For 2 complete revolutions, 2 into 2 pi, 2 perimeters. 2 into 2 pi. That is the distance covered. But displacement 0. Why displacement 0? Means A is the initial position, but A itself final position also. So there is no gap between initial and final position. So initial and final positions coincide with each other. So we don't have any line segment from initial to final. Why? Because both are coinciding with each other. So displacement for complete revolutions, for whatever the number of complete revolutions, displacement becomes 0 in circular motion. Alright? But distance becomes, for one revolution 1 into 2 pi r, for 2 revolutions 2 into 2 pi r, for 3 revolutions 3 into 2 pi r, like. So like that, for n revolutions, mod s bar, that is displacement equal to again 0, but distance equal to n times 2 pi r. For 3 revolutions, again displacement 0, distance equal to 3 into 2 pi r. For 4 complete revolutions, again displacement 0, distance equal to 4 into 2 pi r. For n complete revolutions, displacement once again 0, distance n into 2 pi r, like. Alright? Suppose for half of the revolution, for half of the revolution, what is the angle? See, for half of the revolution means, suppose particle started at A and moves half of the perimeter, like, and reaches diametrically opposite point B. This is the actual path followed by the particle. So A to B. B is the diametrically opposite point. See here, this is the midpoint. This is what? Radius R. This is also radius R. Now what is the displacement? A line segment joining from initial position to final position, like. See, this is the displacement S bar. From A to B is the displacement S bar, vector pointing. But this is the distance. Okay. Length of the arc is the distance. That is half of the perimeter. What is the length of this arc? Half of the perimeter. It's not complete circle. It is half of the circle. That is the reason why half of the perimeter is the distance. Right? Now see, distance equal to r theta. Distance d equal to r theta. That is r into, what is theta here? For semicircle, what is the radius? What is the angle made by the semicircle with the center? Means this is what go center. Theta means pi. Okay, that is half of 2 pi r. Half of 2 pi, 2 pi r. Half of the perimeter. Perimeter means 2 pi r, half of the perimeter. Displacement equal to 2r sin theta by 2. 2r sin theta by 2. That is 2r into sin. What is the angle made by semicircle with the center? That is pi. That is pi. Angle is pi. 180 degrees. Pi by 2. That is 2r sin pi by 2. Sin pi by 2. That is 1. That is 2r. 2r. See, r plus r. Straight away, the line segment drawn from initial position to final position. The length of line segment, that is r plus r. 2r is the displacement. Okay. Now, in another way, one more one. A particle moves through an arc AB of length 10 centimeter. What is the length of arc from A to B? That is 10 centimeter. Okay. Now when particle is at A, this is what radius? Center O. This is also radius R. Now what is the angle made by arc? That is theta. Suppose R equal to 15 by pi centimeter. Arc length, arc AB equal to 10 centimeter. The angle made by the arc is theta. Okay. Suppose a particle moves through an arc AB of length 10 centimeter of a circle of radius 15 by pi centimeter. Now find the magnitude of displacement. Find magnitude of displacement. Find the magnitude of displacement. Right? Find the magnitude of displacement. See, what is the expression for magnitude of displacement? 2r sin theta by 2. We have r value, but we don't have theta value. Theta unknown. We have to find theta initially, right? How to get theta? Instead of theta, we have additional value, that is arc length 10 centimeter. What is the relation between radius and arc? Means arc length equal to radius times theta. What is the length of arc? 10 centimeter. 10 centimeter equal to radius 15 by pi centimeter into theta. 15 by pi centimeter into theta. Centimeter cancel. Now theta equal to 10 into pi. 10 pi by 15. That is 2 pi by 3. Now what about theta by 2? Implies theta by 2. See expression theta by 2. Theta by 2 equal to pi by 3. Pi by 3. Now what is the displacement? Displacement equal to 2r sin theta by 2. 2r sin theta by 2. That is 2 into r 15 by pi centimeters into sin theta by 2. Sin theta by 2 pi by 3. Pi by 3. That is displacement equal to 2 into 15. 30 by pi into sin pi by 3. Sin 60 means root 3 by 2. Root 3 by 2. That is 30 by 2, 15, root 3 by pi centimeters. This is the displacement. 15 root 3 by pi centimeters. Of course, here in another way also we can find expression for displacement. See, I am highlighting this part of diagram. So A, P is the arc. Now what is the displacement? A line segment, straight line segment. This is the displacement. See, this is what displacement. Now what is the total angle made by arc means theta. If I take half angle, I am dividing with one bisector like that. Now this is half angle, total angle theta, this is theta by 2. This is also half angle, theta by 2. Now this is what radius, this is also radius. Right. Let be x, here also x. Now x plus x, 2x is the displacement. See in this diagram, this is what arc length, that is distance. Now x plus x, shortest distance, x plus x is the displacement. That is 2x is the displacement. Now take sine theta by 2 in any one of these triangles, right angle triangle, see right angle triangle, here also right angle triangle. Sine theta by 2 equal to x by r, opposite side x by r, here also x by r, x by r. That is x equal to r sine theta by 2, r sine theta. Now twice the x plus x, 2x, twice the x is the displacement. 2x equal to r sine theta. This is what displacement. See expression. Displacement 2r sine theta by 2. Okay, already we came across 2r sine theta by 2 displacement. Here also, in this method also one can find expression for displacement 2r sine theta by 2. So in both methods we can have same expression for displacement in case of motion along arc or circle. That is 2r sine theta by 2 is the displacement, r theta is the distance. Okay friends, thank you once again for watching. Bye bye.